Hi students, welcome to ALPHORES e-learning program maths class. In this session students, we want to discuss about reflection property, one of the important concepts. This one very useful even in the daily life also, daily life in the sense while wars are going on and how flights they have to target any other location etc. This property, basing on this property, this is useful. Okay, let us observe here what is the reflection property. Now observe students, we have taken example of y square equal to 4ax parabola. Now in this parabola, you can know in previous session we have done this property, that is st equal to sp equal to sn, where t is exactly the tangent drawn at the point P and it is meeting x-axis, that means axis of parabola at the point T. And next one, n is nothing but here when normal drawn at P and meets the axis of parabola at n, s being of course focus of parabola. Okay, then st equal to sp equal to sn we have done in previous session already. Basing on this one, just we have taken a tangent just at the point here, this is P, and of course this one is our directrix. All of you know SP is same as how much here, PM, when this line is nothing but a directrix. So this is our directrix line, right? And now you have taken a tangent drawn at the point P and it is meeting x-axis at this point T. Then what is our observation? As we have done already st equal to sp, therefore this and this, these two sides are equal. Okay, these two sides are equal, implies this triangle is nothing but an isosceles triangle. And suppose this angle is alpha, okay, it is making some inclination with this x-axis. Let us take this angle as alpha. These two sides being equal, therefore exactly this opposite side also here alpha, because these two are equal, their opposite angles also must be equal with the property of isosceles triangle. Now these two are equal, at the same time this one is exactly P to M perpendicular, which is parallel to axis of parabola. And if you extend this line students, you can observe as this angle is alpha, therefore this is also alpha. Implies what happened here, the tangent is becoming exactly the angular bisector of the lines SP and PM. Okay, the tangent is becoming here the angular bisector of SP and PM. Moreover, it is bisecting internally. Okay, SP and PM, it is the tangent is bisecting internally. Therefore, this is internal bisector of angle between the lines SP and PM. Okay, so this result, of course, if you take here alpha, immediately this is alpha, we also know very well. But how you got this angle also alpha? Basing on this result. Okay, based on this result, this value also here alpha. Of course, you know about these two values. If it is alpha, this is also alpha. But how we got this is alpha means just basing on this relation. So immediately we observed that this line tangent is nothing but the internal angular bisector of the lines SP and PM. Then what will happen? Immediately the normal, okay, normal. Then you observe here, this is of course 90 degrees, this is alpha means this one also alpha because this is a horizontal line. And if it is alpha, this is 90 minus alpha because the line is normal, which is perpendicular to tangent. Therefore, you can observe as this tangent is the internal angular bisector, the normal is becoming here external angular bisector of same lines SP and PM. Okay, if you observe PM like this here, this one is nothing but PM. Therefore, to these two lines, okay, to these two lines, this normal is now again bisector of angle, but at the same time it is the external bisector of angle between SP and PM. Okay, now once we got this property students, what is the use of this property? Suppose an incident ray, isn't it? If incident ray is exactly parallel to axis of parabola, if incident ray is coming from positive direction of x-axis towards the parabolic mirror, okay, if incident ray is coming like this towards the parabolic mirror, immediately it get reflected and the reflected ray passes through which one here? The focus. Okay, because this is normal, these two are here equal angles, 90 minus alpha, 90 minus alpha. Hence, if incident ray is coming towards like this, understand, that means it is exactly parallel to what? Axis of parabola. If incident ray is coming parallel to axis of parabola, then the reflected ray always passes through which one? Focus of that same parabola. A very, very, very important concept. For example, if I am taking like this, okay, this is our parabola and the point is here fixed. This is focus, it is a fixed point. Now incident ray is coming parallel to this one, okay, the axis of parabola, strikes the parabolic mirror, immediately it get reflected in this way, okay. And next one, suppose another incident ray is coming again parallel to this one, that means it is coming like this, parallel to axis of parabola, strikes the parabolic mirror, again it is passing through which one? Same point, that is here S only. Understood? Again here it is coming like this, then this one also passing through which one here? This one only, okay. And again here if it is coming in this way, it is getting again back, isn't it? This kind of property you have done already in physics. And if I am taking this one is below the axis but it is parallel. Now what about the reflected ray? It is passing through same focus like this. Again incident ray is coming in this way and it is passing through focus. Therefore students, clearly you can observe, basing on this property, many science things they have developed, okay. In science, in physics, they have developed so many concepts just basing on this concept, that is here, whenever incident ray is parallel to axis of parabola, then the reflected ray is always passing through a fixed point known as here focus of that parabola, okay. Now basing on this, now we can do some problems, but this property is very, very important property, right? Now let's observe students, this problem seems to be so many lines are there in the problem, but it is just a small concept. Observe, a ray of light moving parallel to, okay, a ray of light moving parallel to x-axis and gets reflected from a parabolic mirror, okay, using the equation, whose equation is given. That means this parabola is what kind of parabola? Whose axis is parallel to x-axis. Now what they are asking, the point on axis of parabola through which the reflected ray is passing, okay. So what is the point? Just now we have observed the point is nothing but here focus, okay. So that means here to this parabola, what you need to find here? The value of, that means coordinates of focus, okay. So this is the importance of this property. Easily you can say here the reflected ray is passing through focus. That means here we need to find which coordinates? Focus coordinates. Of course all of you know how to find here focus coordinates. What is our 4a value here? It is 4, implies a equal to 1 here, and it is of the form y square equal to 4x, okay. Y square equal to 4x kind of parabola. Therefore focus is nothing but here it is 1, 0, okay. 1, 0, this is our focus, a, 0. But what about here this one? That means what is the vertex of this parabola? -1, 2. Therefore that value just add here -1 and here +2. Therefore what is our focus here? 0, 2. Therefore the incident ray, whenever it is moving parallel to axis of parabola and get reflected with respect to the parabolic mirror, then the reflected ray is passing through the focus, which is nothing but 0, 2. Now observe students, basing on the previous property, actually if I consider from focus, this one is here, SP we have taken, where the tangent is drawn at the point P to the standard parabola y square equal to 4ax. But this property we can apply to any kind of parabola, just like our reflection property, whatever we have discussed, that also we can apply for any kind of parabola. Now here also you can make use of this property for any type of parabola. The importance of this property is, students, it is nothing but here, if you take a tangent drawn at P, okay, if you take a tangent drawn at P, then we have observed already ST is equal to how much here? SP. Okay, ST equal to SP, and next another property we know clearly here, that means again this SP is equal to what again? PM also. Okay, SP is equal to PM. Then the image of focus, okay, the image of focus with respect to the tangent drawn at any point P on the parabola. Wherever you take tangent, okay, at any point P on the parabola is always how much here? On the directrix, okay. The image of here focus, okay, the image of focus, this one with respect to tangent drawn at any point on parabola lies on directrix, okay, just basing on that previous concept. And in this one you can make use of like this also. Suppose you have taken directly from here to here a line, okay, suppose it is meeting. If that is meeting tangent at vertex at this point, if these two are there and if you are able to connect these one, that means somewhere it has to be connected, and from there I am taking tangent. Suppose this is the position you got, then this is our foot of perpendicular, and now these two are here at right angle, then this one is here it is isosceles triangle. And in that way students we can say here clearly the image is nothing but, that is image of focus is nothing but which one here? The point on directrix. And at the same time here you can observe one more thing also, that is this P and TR, okay, this P and TR. What is the T value here? The point T where it is meeting axis of parabola are images of one another with respect to foot of perpendicular which is drawn to tangent at vertex from focus, okay. That means with respect to this point, not with respect to the line we are calling, it is with respect to this point, okay. P and T are images of one another, okay. So that means here Q is exactly what? Middle point of P and T. So Q is middle point of P and T. You can make use of this concept very easily, and in this way students these two properties are very important. That means image of focus with respect to tangent drawn at any point on parabola lies always on directrix, okay. And the other one is nothing but, if this is the foot of perpendicular drawn from focus on which one? Any tangent, okay, on any tangent, always you know it is always on tangent at vertex, because of the reason the locus of feet of perpendiculars drawn from focus on any tangent lies on tangent at vertex. Therefore Q is a foot of perpendicular implies these two are again images of one another, implies PQ is equal to what here? QT, okay. So these two are very important, just basing on our previous concepts, right? Now observe students a problem, that is let 3x minus y minus 8 is 0 be a tangent to a parabola drawn at the point 7, 13. Okay, so this is the tangent equation drawn to a parabola at the point 7, 13, and if focus of parabola is given, okay, focus of parabola is given, then they are asking about what is area of triangle formed by directrix and with coordinate axis. So this is the problem students. That means once you know equation of directrix, you know about here the area of triangle formed by a line with coordinate axis, formula c square by 2 mod ab if the line is of the form ax plus by plus c equal to 0, okay. That means what is our intention in this problem? Major step you have to go for is directrix equation. So how to find equation of directrix under this data, okay. So what is given actually, of course this one is the standard parabola, but I am just comparing, okay. So what is the equation of this one is tangent. That means this equation is given as here nothing but 3x minus y minus 8 is 0. Of course this data is not for this one, for oblique parabola, okay. So this one is tangent, that means it is of like this tangent given drawn at the point, the P coordinates point of contact given as 7, 13 at they gave, okay. At whenever it is given implies the point is on the parabola, right. And now what is the other data given? Focus of parabola is minus 1, minus 1. That means this focus is nothing but how much here? Minus 1, minus 1. And now they are asking about area. So what is the data given students here? The tangent equation is given 3x minus y minus 8 equal to 0. Tangent equation is given, focus is given, okay. And next one is here the point of contact given, that is 7, 13. I am just using this one as here but conceptual purpose, but diagram is not in this way. Diagram can be like this or like this, it can be, okay. So just for concept we are using the diagram. And now what are our requirements to obtain here the equation of directrix? Okay, now once this point, students, it is 7, 13, that is point of contact, right? And this one is focus, and this is equation of directrix. Now one of the points you can find easily, that is nothing but what here, image of focus with respect to this line, okay, with respect to this tangent lies always on what here, directrix. Okay, image of focus with respect to this one, that means tangent at any point P lies on directrix. So that concept easily we can get. But before to go in that way, students, what we want to do is here, let us find even foot of the perpendicular also. What is the advantage of foot of perpendicular? Because here directrix only one point you cannot find the equation. Okay, you need at least 2 points or slope of directrix, but here you don't know those. That's why we are taking here 2 points we require. That's why I want to find, instead of directly finding image, let's find here foot of perpendicular, which is drawn from focus onto tangent drawn at the point P. Okay, so now let us take here foot of perpendicular drawn from focus to tangent at vertex, isn't it? To this one, this is nothing but how much here, h plus 1 divided by 3. That means what are coordinates? If this is hk, then our formula h plus 1 divided by this is 3, and k plus 1 divided by the coefficient minus 1, and minus of, you know, it is here you substitute minus 3 plus 1, okay, minus 2 minus 8, so minus 10 divided by 9 plus 1, that is 10. So this is 1. That implies h is 2 and k is minus 2. Implies the foot of perpendicular we got how much here? It is 2 comma minus 2. So once you got this foot of perpendicular, students, which is 2 comma minus 2, now our interest is what here? To obtain point on directrix. Okay, so one point on directrix we can take, as this is the foot of perpendicular, we can say clearly q of 2 comma minus 2 is midpoint of which one? Actually midpoint of, it is focus, yes, understand, focus, yes, and a point on directrix. Suppose you consider it as m, a point m on directrix. Okay, a point m on directrix. Now focus coordinates, you know what are focus coordinates given? Minus 1 minus 1 comma m coordinates we don't know. Suppose let me take this m coordinate as here alpha comma beta, right? Then what about our formula? This is the middle point, and now requirement is about the point m. Okay, then you can make use of the concept 2x minus x1 comma 2y minus y1. If x1 y1 comma x2 y2, these are 2 points given, and this is our point x comma y, then the middle point already you know. So to find x2 y2, simply you can write 2x minus x1 comma 2y minus y1. So directly you can find here this x2 comma y2, the other end of the value. Therefore if I use this formula here, then the point, suppose m you consider, it is 2x 4 minus of minus, it is plus 1, okay, and 2y, that is minus 4, and minus of minus, it is plus 1. Therefore the value is 5 comma how much here? Minus 3. Therefore you got, students, 5 comma minus 3 is the other end of this line SQM. Okay, now you got one point on directrix. Then what about the other point? How to obtain another point on directrix? Let's make use of here again the concept, that is P and T are here images of one another with respect to q. Okay, what is q value you got? It is nothing but 2 comma minus 2. This is the point you got. Then you can find here t value. Okay, what is the advantage of here t value here? Once you know t value here, s value already you know, then you can find here the slope of line joining, which is nothing but axis, and directrix is always here perpendicular to axis. That is the intention of here finding the value of t. So how to find here coordinates? Again, this is the middle point, make use of same kind of definition. Therefore the t value is nothing but here coordinates of t we are going to find now. So t coordinates are nothing but here, it is 2x minus x1, and the middle point is here 2 comma minus 2, therefore 4 minus of here which one, 7 comma the other value is minus 4 and minus how much, 13. Okay, so these are t coordinates. Because of what reason? Q is midpoint of P and T. Then this is nothing but how much, minus 3 comma minus 17. This is t. And what about S value here? S value is minus 1 comma minus 1. Therefore what about here, slope of ST, right? Slope of ST is equal to nothing but here minus 17 plus 1, that is minus 16, divided by minus 3 plus 1, that is minus 2. Therefore this is equal to how much, 8. And hence slope of directrix, what is slope of directrix here? The slope of directrix is nothing but minus 1 divided by 8. Okay, so therefore slope of directrix is equal to minus 1 by 8, as ST is lying on axis of parabola. Okay, since ST line is along axis, okay, along axis of parabola, and axis is perpendicular to directrix, hence we got this value. Then what about now equation of directrix? So you know slope and you know already this point, therefore equation of directrix is nothing but how much, it is y plus 3, right? Y plus 3 equal to the slope minus 1 by 8 and into x minus 5, right? That implies if you cross multiply 8y plus 24 is minus x plus 5. And if I write all values on one side, if you write all values on one side, then this is nothing but x plus 8y 24 minus 5, that is 19 is equal to 0. So students, this is our equation of directrix. And once this directrix equation you got, what is our formula for area? Area formed by, okay, area formed by directrix, okay, area formed by directrix with coordinate axis. So with coordinate axis is equal to, what is formula? 2c square divided by mod AB, and here it is nothing but 2 into 19 square divided by mod AB, sorry, c square divided by 2 mod AB. Therefore here it is nothing but c square by 2 into 1 into 8. That implies you can say clearly 19 divided by 4 whole square, square units. So this is nothing but here area of directrix formed with coordinate axis, right? Now observe students, this is another problem. The data given as here, y equal to x plus 1 is axis of parabola, y plus x equal to 4 is tangent drawn at the vertex, and y is 2x plus 3 is one of its tangent. Okay, so what is the data given? This is axis of parabola. Okay, this is axis of parabola given, that is y is x plus 1, and next one is y plus x equal to 4 is tangent at vertex. So this is y plus x is 4 tangent at vertex, and y is 2x plus 3 is one of its tangent. To a parabola many tangents can be drawn, so other than tangent at vertex, this is the tangent drawn to the parabola whose equation is given as y equal to 2x plus 3, and this is the point of contact. Then what about here questions? They may ask this question as a paragraph or more than one answer. Anyways, they can ask here. The first one is, what is equation of directrix? And once you know about equation of directrix and focus, of course you know about equation of parabola using the formula SP equal to PM. And next one they are asking about point of contact. That means this point of contact of tangent with the parabola. So the point P, how to obtain. Okay. So to find this one again, however we have done in the previous, the concept is the same. What is the concept here? The focus, whatever here you are taking focus here, the foot of perpendicular drawn from focus on any tangent lies always on tangent at vertex. Okay, so basing on this point, and at the same time here Q is exactly middle point of this P and T. Okay, Q is middle point of this P and T, and basing on this concept students, now we are going to solve this problem. First of all, here q value already you know you can find because of what nature? This is nothing but what here? Point of intersection of tangent and tangentiate vertex. So both the equations are known, given. Therefore, you can find clearly here coordinates of q. So what about here coordinates of q? If I can write here, the q coordinates are nothing but if you substitute y plus x is 4, y is 2x plus 3. If I substitute here, so for q I am writing here, for coordinates of q we are substituting here point of intersection. So it is nothing but 2x plus 3 plus x is equal to how much? 4. That implies 3x is equal to how much? 1, and x is equal to 1 by 3. Once x is 1 by 3, substitute here y value, then y is equal to how much here? 2 by 3 plus 3, that implies 11 by 3. So that here what are our q coordinates? 1 by 3 comma 11 by 3 we got. Okay, so these are our q coordinates. Once you know about q coordinates, students, again you can make use of here the concept, that is here the tangent drawn from focus on any tangent. Okay, it is always meeting the tangented vertex exactly at the right angle. That means SQ is here perpendicular to which line? Tangent, because this is our tangentiate vertex, the locus of theta perpendiculars drawn from focus on any tangent, always they are on tangentiate vertex. Basing on that condition, we can say clearly SQ is here perpendicular to tangent. Hence here, even though you don't know about coordinates of focus, then how to obtain that? Basing on this concept. Now as S is on axis of the parabola, okay, so if x value you take alpha, then y is how much here? Alpha plus 1. So we want to reduce here a number of unknowns. If I take x as alpha, then y is alpha plus 1. Now here we have taken focus coordinates like this, and q coordinates just now we found using the solving of the two lines. And now here we are going to make use of the relation SQ is perpendicular to which one? Tangent drawn to the parabola at a point P. Now what is slope of SQ? Then into slope of tangent at P is minus 1, because they are perpendicular. So SQ slope means what is the value here? Alpha plus 1 minus 11 by 3, right? And divided by the other value, that is alpha minus how much? 1 by 3. And into what about here? Slope of tangent drawn at the point, that means this one, the slope is here 2, okay, and into this is equal to how much? Minus 1. So this is equal to minus 1, and thereby what is the value you can get here? This is alpha, and next here 3 alpha, and here 3 minus 11, so minus 8 divided by 3 alpha minus 1, and into 2 you are having here, this is equal to minus 1. Then if you take here cross multiplication, okay, so if you do cross multiplication, what about the result? The cross multiplication, that is 3 alpha minus 8 into 2 implies 6 alpha minus 16, okay, 6 alpha minus 16 equal to 1 minus 3 alpha. That implies here, if I write in this way, 9 alpha equal to 17. That implies alpha is how much here? 17 divided by 9. Then what about the ordinate here? Alpha plus 1. So alpha plus 1 is nothing but how much it is? Nothing but 26 divided by 9. Therefore here coordinates of focus, nothing but what we got? 17 by 9 comma 26 divided by 9. So these are coordinates of focus we got, right? And once you got here coordinates of focus, then everything we can do in few, that is few steps. That means here what about q value here? Actually it is midpoint of point on directrix and this value s, okay. So point on directrix, suppose you consider as m, then here m is exactly middle point of what here? S and this m, that is q is middle point of s and m. Therefore now we can consider, students, a point on directrix, okay. Point on directrix, suppose you consider m, and that is exactly here which segment q, okay. So I am writing q is midpoint of which one here? Sm, okay, Sm, where m is what here? M is which point here? Image of, okay, m is image of here which point? Focus. Focus S with respect to what here? With respect to tangent drawn at a point P. Okay, tangent drawn at the point P, because we observed the concept that is the image of focus with respect to the tangent drawn at P always lies on directrix. So that is our M. As M is the image with respect to that and Q being the foot of perpendicular on the same line, that is on the same tangent, therefore we can say Q is exactly middle point of S and M. Hence now you know coordinates of S here already we got to know, and Q coordinates also you know. Therefore here we write S is how much we got? 17 by 9 comma 26 by 9, and next Q value how much we got here? That is 1 by 3, 11 by 3, and hence M value we want. Okay, so what about M coordinates here? M coordinates are nothing but here 2x, this is the middle point. So 2 by 3 minus 17 by 9 comma this is 22 by 3 minus 26 divided by 9. Then here if I multiply 6 minus 17, 6 minus 17 means minus 11 divided by 9, and here 66 minus 26, that is here 40 divided by 9. So these are coordinates on directrix, right? And once students you know about coordinates on directrix, then what about here? Equation of directrix. Of course in this problem they gave tangent at vertex as well as this axis also. So you can make use, directrix is parallel to which one actually? Tangent at vertex. Therefore slope of directrix is nothing but minus 1, right? As directrix is parallel to tangent at vertex, therefore slope of directrix is minus 1. Hence what about now equation of directrix? Okay, so equation of directrix is nothing but, so equation of directrix is nothing but here point already you know, that is y minus 40 divided by 9, okay, is equal to, now the slope we came to know it is minus 1 and into x minus of minus, now it is plus, okay, 11 divided by 9. Now if I write the values on one side, that implies x plus y equal to 40 by 9 and minus this is 11 divided by 9. That implies 40 minus 11 means the value is 29. So x plus y is equal to now 29 divided by 9 implies 9x plus 9y minus 29 equal to 0 is nothing but our equation of directrix, right? Now students, you came to know about equation of directrix and you know about focus coordinates, then just make use of the concept SP equal to PM, thereby you can find now equation of parabola. And how to obtain again now point of contact, right? Point of contact means here you know about this point, that is 1 by 3 comma 11 by 3. And if you solve this line, okay, that is the tangent drawn at P, and next another line that is axis, okay, if you solve these two equations you can find easily which point here? T coordinates. Okay, once you know T coordinates, Q coordinates, just however we have applied in the previous problem, that is Q is middle point of P and T. Okay, Q is middle point of P and T. Therefore, you can obtain easily which one? Point of contact. And if at all they ask latus rectum length in the same problem, length of latus rectum, then you can make use of the foot of perpendicular distance from focus. Coordinates already you know. The perpendicular distance from focus onto tangent at vertex, that is you know small a. Okay, then 4 times that distance is nothing but length of latus rectum. So in this way, once you know about focus coordinates, directrix value and these other data, then easily whatever the question they ask, easily you can obtain basing on our known concepts, right?